What a day. Once again, Johnny is able to get up for another beautiful day thanks to his trusty alarm clock. In fact, all over the country, people are getting up to start their days the very same way.
Dude.
How does this miracle of modern civilization do it?
Who are you?
How does the alarm clock keep track of time so precisely to the very second that Johnny needs to get up?
Who are you?
All this and more
What are you
is
doing
due
here?
to the amazing phenomenon of
What are you doing?
the Piezoelectric Effect.
Get out!
But how does it actually keep track of time down to the millisecond? If there was only a way to produce something that could be measured every single second on the dot, obviously the alarm clock is powered by electrical current, or else the alarm clock wouldn't go off, and little Johnny wouldn't wake up on time. In order to keep track of time, we need the current to flow at a very specific pattern. If there is a pattern that occurs, for example, at every second, we know that after the current has reached its peak, exactly 1 second has gone by. But how do we obtain this unwavering, precise electrical pattern? The answer is the piezoelectric effect. Let's break down this effect. The piezoelectric effect only happens in materials with well-defined crystal structures, such as quartz, topaz, and bone. Piezo comes from the Greek word for pressure, so the piezoelectric effect happens when pressure, or stress, is applied to these materials, which causes a buildup of charge. We know that a buildup of charge causes current to flow in a circuit. Similarly, when a current is applied to a piezoelectric crystal, the buildup of charge causes a stress. Therefore, when you apply a current to, say, a thin piezoelectric crystal, it will vibrate in relation to the current, and then produce a current based on that vibration. But how do we get the well-defined vibration needed to keep track of time with these materials? Wouldn't it be nice if there was some property about materials that caused them to vibrate in a consistent way? Luckily for us, we have resonance. Objects tend to vibrate more easily at a specific frequency. This special frequency, determined by the object's internal structure, is called the resonant frequency. Take Susie on the swing here. If I give her a hard push, it takes her a certain amount of time to get back to me, or to complete 1 cycle. Now I'm going to give her a soft push. It still takes her the same amount of time to complete 1 cycle. The time it takes to complete 1 cycle is the swing's resonant frequency. I can give any number of pushes to the swing, and it will still tend to swing at this frequency. Objects, too, tend to vibrate at a specific frequency called their resonant frequency, even when a lot of different forces are applied. In this way, the object structure acts as a filter, which tends to vibrate toward the resonant frequency. Now look at this cup. Right now, little Bobby is applying a mechanical force on the top of the cup. This force causes the glass in the cup to vibrate at its resonant frequency. Listen. You can hear this resonant frequency as a sound wave. No matter if you circle slow or fast, it's always vibrating at this frequency. We know this because the sound is always the same pitch. Now that we understand resonance, let's look back at the alarm clock. It all starts with a source that sends current into a quartz crystal at a mixture of many unfiltered frequencies. Remember the 2 parts of the piezoelectric effect. Firstly, those electrical frequencies cause the quartz to vibrate mechanically at its resonant frequency. Secondly, the vibrating quartz then produces a current. The current's frequency is the same as the quartz's known resonant frequency. Again, say the current's frequency is 1 cycle per second. We then know that after each cycle, exactly 1 second has passed. And that, folks, is how the alarm clock works. And now, a journey into the future. Imagine a world in which sidewalks generate power from someone stepping on them. Mechanical force would cause the sidewalk to vibrate and produce a charge that could power devices and even enter back into the power grid. Imagine every pair of shoes having a piezoelectric sensor that converted the pounding from walking into useful energy. All this, and more, becomes possible thanks to the piezoelectric effect.